Hi, in this video I'm going to cover quicksort. Quicksort uses recursion to solve the problem, and the way it works is that it picks what it calls a pivot point and splits the list up based on that pivot point. Picks a pivot point and then tries to move all the numbers that are smaller to the left and all the numbers that are greater to the right. But it keeps breaking it down into smaller and smaller pieces until it is down to 2 to where then it can do that. So it runs pretty fast. We're going to test it out here and see. So first thing we need to do is create our quick sort. We're going to pass in a list. And then the only thing we're going to do in here is call quick sort helper, passing in a list first, 0, and length of a list minus 1. So calling quicksort just gets it started, and then we're going to do the quicksort helper here. So we're going to on the quicksort helper, we're going to pass in a list first and last. And here, we're going to check to see if first is less than last. This is our base case. Then we're going to split point. That's going to be equal to another method we're going to call, or function, partition, passing in a list first and last. Then we're going to call quicksort helper, passing in a list first and split point minus 1. Okay, out there. And we're going to call quicksort helper again, passing in a list, split point plus 1, and last. That's all there is in there. So this is the big part here. This is the partition. Going to receive a list first and last. So in here, we're going to set up our pivot value. And that's going to be equal to a list sub first. So our left mark is going to be equal to first plus 1, and our right mark is going to be equal to last. I'm going to set done equal to true. Oh, wrong one, sorry, false. Once we get it done, then we'll set it to true. So now, while I'm not done, while left mark is less than or equal to our right mark, and a list sub left mark is less than or equal to our pivot value, we're going to set left mark equal to left mark plus 1. And that ends that while loop. I'm going to do another while loop. While a list right mark is greater than or equal to pivot value, and right mark is greater than or equal to left mark, right mark is going to be equal to right mark minus 1. Okay. So what we're doing here is with the left one, we're marching our way down until we find a value that's in here on this side of the pivot value that is greater than our pivot value. Okay, until we get to that mark there. Okay, and then so we're going to keep moving until we get the left mark over. Okay, then we're going to do the same thing with the right side. Okay, so now if right mark is less than left mark, done will be equal to true. Okay, else we're going to do a swap here. Temp a list. Put that off of here. Temp equals a list left mark. A list left mark is going to be equal to a list right mark, and a list right mark is going to be equal to temp. Okay. So at this point, if done becomes true, then we're going to drop out of this outside while loop here, and that's where we'll do one last swap here and here. So this is then in here, we go. Temp is equal to a list first. A list first is equal to a list right mark, and a list right mark is equal to temp. Okay, once we get all that done, then we're going to return right mark. So let's test this out. Create a list, do 1, 5, 8, 4, 2. Okay. I'll quick sort, passing in list, and then print out our list that should be sorted, I hope. Okay, let me get this saved. Well, I've already got it saved. I just got to resave it. So I'll do it and run, and then yes, I want to resave it. And there we have our list sorted. Okay, so that all worked out. Just to prove it here, just one more thing real quick. I'm going to put a print in here. Print list. There we go. Mixed up list, sorted list. So now what we're going to do is test this with, like I did in my other ones, if you happen to see those, with the different sizes of lists. So you can see how it does with really large lists. So I'm going to start off with list. Oh, let me go up here first and get this taken care of. I need to put in here, I need to bring in some modules. Do an import on random and an import on time. Okay. So list is going to be equal to a bracket end bracket. In file is going to be equal to open numbers tenthous.txt, opening that up for a read. Then we do a for num in file list.append num. Okay, and then we're going to go ahead and close the file. And then we want to shuffle our numbers. So we do a random shuffle list. Get our start time. Call our sort. Passing in our list. our end time, and then print out our results. So we do time for 10,000, end minus start. Okay, I think I've already got my main in there, right? Yep. So let's run this and see what happens. And there we go. For 10,000 numbers, it took 0.42 seconds. Quite a bit more than the other two. Other two were less than a tenth of a second on there. So I'm going to modify this, but I'm going to do it a little bit different on here. I'm going to just take this here, do a Control C to copy it, put a blank line in here and do a paste. Blank line in here and do a paste. And then I'm going to go up here and change these. Change this to my 100,000. And then change this to 100,000. And then change this to my 1 million. Do that there. And then change this to 1 million. Okay. So this way, when we run this, whoops, got an error in there. Get this to stop. Okay, so this is the problem with some of these. The maximum recursion depth exceeded in comparison. Okay, so it doesn't like the 1 million here, so I couldn't do that one. I'm going to go ahead and let's take this down to, we had it at 100,000. So we'll just delete this out of here and we'll just look at the two. It's one of the problems with some of these. When you do these, if you have in recursion, if you have too many numbers, then it overflows the system, which is what that did there. So what we worked for the two, we can see what it is for both of these. This runs similar to what a merge sort does. Shell sort runs pretty quick too. So just to make a comparison, and all of these run a lot faster than the first ones we did. In the previous ones on the shell sort, insertion sort, and bubble sort. So hope you enjoyed this and got some information out of it. And stay tuned for other videos later. Bye.